Olá, nós estamos no 10º Congresso Brasileiro de Melhoramento de Plantas em Águas de Lindóia, interior de São Paulo. Pesquisadores, estudantes, professores e diversos profissionais da área estão tendo a excelente oportunidade de assistir palestras sobre o melhoramento de plantas e interagir com pesquisadores nacionais e internacionais que estão trabalhando com o que tem de mais moderno em melhoramento e em áreas relacionadas. Nós, o GEVENC, o Grupo de Extensão em Genética e Melhoramento de Plantas, com o apoio da Sociedade Brasileira de Melhoramento de Plantas e o GENT, que é o Grupo de Comunicação e Divulgação Científica da Exalc, entrevistamos alguns dos palestrantes que estão presentes aqui hoje. Os entrevistados de hoje participaram do Smart Tools for Plant Breeding, uma série de palestras com renomados pesquisadores internacionais, com o patrocínio da Corteva AgriScience e o suporte da Sociedade Brasileira de Melhoramento de Plantas. Nós estamos aqui com o pesquisador Ed Buckler, da USDA. Hi, Dr. Buckler. It's a pleasure to have you here. To start our conversation, could you please talk a little bit about yourself, your research path in science, and how you came up being a researcher at the USDA?
Yeah, so starting out very young, I was interested in computer programming. And then when I got to high school, I started to learn more about genetics and realized genetics really is programming, but with life. And then as I went to college, I got degrees in both biology and archaeology. And archaeology taught me a lot more about agriculture and how people produce food around the planet and how important it was that we do that well and efficiently. And so I did my PhD combining those two areas together. And then after that, I started doing more work in statistics and then genomics. Started up a lab first in North Carolina, working on genomics and breeding. And then the last 15 years, I've had a USDA lab at Cornell, combining those two together.
Oh, interesting. And concerning your main research lines, how can they reflect in current plant breeding programs?
So it's evolved over time, but some of the first things we figured out were, for example, how to take varieties, genetic variation in maize, and that may control provitamin A levels. So this is what makes white versus yellow corn, and there are ways to get very high levels of provitamin A. So I and some colleagues, we identified some natural variation that increased levels of provitamin A. It turned up by almost 30-fold. And then breeders have been able to pick up that genetic variation and deploy it. So now in Zambia and Zimbabwe, there's varieties of maize with very high levels of provitamin A that's helping malnutrition. We also have developed statistical approaches that allow people to identify the genes that are controlling various traits, and those have been applied across the world to understand various traits. And finally, we've developed molecular approaches to follow breeding patterns, follow genetics and crosses, and those molecular approaches have been used also around the world for breeding.
Oh. And how do you think an event like the 10th Brazilian Congress of Plant Breeding that we are having here this week can impact the future of Brazilian agriculture?
I think the really exciting thing about this Congress is the diversity of people it's bringing together. It's bringing people from undergraduate to very senior scientists, and just that interaction, discussion with one another about the future of agriculture, and all of us learning from one another is really what drives the future together.
It's an event for everybody.
Yeah.
And your talk here in the Congress was related to the Emerging Breeding 4.0. Could you please tell us what this term, Breeding 4.0, is referred to, and what are the main breakthroughs we will have in genetics and plant breeding in next years?
Mm-hmm. So prior stages of breeding have all worked only with the natural variation that's within the species. And we've made a lot of progress with breeding with those types of approaches, but there's now more efficient ways to take some of that variation or add new variation to our crops to adapt them. And this may be through transgenics, or where a lot of the future is going is through genomic editing. And what Breeding 4.0 is about is how do we find the single base pairs that we may want to change, or little pieces of DNA that we may want to change, and then use genomic editing to advance that.
Okay. And a specific issue that breeders have been challenging is how to deal with deleterious mutations that crop genomes present. Could you please tell us more about how this can be handled in maize breeding programs, for example?
Mm-hmm. So every generation an organism has random mutations. In the case of maize, about 90 mutations occur just from the time when that seed germinates to when it starts producing seed. And because of that, a few of those mutations are not very good for the plant. And over time, those build up. And so when we talk about deleterious mutations, we're talking about how do we efficiently get rid of those deleterious mutations and in order to make our plants more vigorous and grow better under a wide range of different conditions. And so I talked today a lot about the various ways to identify those bad mutations. And then I think there's numerous opportunities then for applying that knowledge and then eliminating those bad mutations from our breeding programs.
Okay, so this was the interview with Dr. Buckler. Thank you for participating, for accepting our invitation. Obrigada, pessoal. Espero que vocês tenham gostado da entrevista. Não deixe de acompanhar a gente nas mídias sociais do GEVENC, que estão aqui na descrição do vídeo. Obrigada.